Video poker. It's that thinking person's game for those who, let's face it, don't like to do a lot of thinking. Well, I guess blackjack would be the ultimate not thinking person's game, but video poker is around that same realm. Welcome to the CS302 assignment 5, which we're going to implement this video poker type game. The whole idea is we're going to be given a set of cards, the standard 5-card draw. So you're given 5 cards initially. You can, of course, select which cards you want to give back, and you can trade them in for new cards as you do for regular poker. And of course, you have to output the rank of that hand. So let me go ahead and click on this following link right here. This link gives you sort of the list of all the possible poker hands. Let's go ahead and click and just see what this gives us. Okay, let me try to zoom in on this a little bit. So here are the different ranked hands in poker, from highest to lowest right here. So Royal Flush is the highest rank, which is a very not so likely hand to have, but since we are going to be using standard input to read in our card info to test out our game, we will encounter a Royal Flush, which is very unlikely, but you know, we'll have it happen in our program. Royal Flush is a sort of a hand that has 10, Jack, Queen, King, and Ace, all in the same suit. It's the highest form of a straight flush. Now, a straight flush is a set of cards that are in order, so 4, 5, 6, 7, 8, and they're all the same suit, but not the highest sort of straight flush. So basically, our card, sort of our, if you were to sort our cards, of course, the order has to be 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Jack, Queen, King, and Ace. So basically, 5 cards you have in your hand. If those 5 cards are consecutive, we have a straight. Now, 4 of a kind is if you have 4 of any card. So 4 jacks, or say you had 4 queens, or 4 deuces, or 4 sevens. That would be a 4 of a kind. A full house, definitely my favorite hand to get whenever I play poker with friends. Whenever I play Texas Hold'em, I love getting a full house. A very nice hand. It's very hard to beat this hand, actually. But a full house is really if you have a 3 of a kind of one card and 2 of the other. So here we have 3 tens and we have 2 nines. So we have a full house, 10s over 9s. You're also going to have, 3 sevens and 2 10s. It just basically that's what a full house is. So a flush is if all 5 cards are all the same suit. A straight is just when you have cards that are sort of consecutive of each other, but they're not in the same suit. 3 of a kind. So So whenever I say same suit, that means like, let's say here for 9 we have clubs, diamonds for 8, spades for 7. Those are our suits. So we have 4 suits in total. We have diamonds, hearts, spades, and clubs. So for a straight, that means that we have 5 cards in sequence, but not in the same suit. Okay. Now, 3 of a kind is when we have just 3 of any card. Like here, 3 sevens over here, and the other 2 cards are not really, they don't really add to that hand. 2 pairs, well, we have 2 different pairs. So like in this case here, we have 2 4s and we have 2 3s. A single pair or just a pair is when you have a pair of 2 cards. So here we have 2 aces. Then we have this high card. So that's if, let's say, we don't have any possible hand. So for example, in this 5-card hand, as you can see right here, it's a jack high hand because the highest ranked card in this set of 5 cards is a jack. So that's really all there is to the poker hands. So now I'm going to go over just an overview of what we want to maintain or the structures needed to implement this game. Then I'll go ahead and I'll draw out the pictures to help us see how we can make sense of all of those data structures. Okay, so for our data structures we're going to have a set of maps. So unordered map, which is going to be a hash map. And a map is going to just be really it's a red-black tree or a balanced binary search tree. Now, of course, in this assignment, you can actually avoid able to avoid having a map at all. But the purpose of this program is to really practice using a map. And also using a map makes it much more simpler to verify a hand at the very end. So let's go ahead and go through these maps. So the first one is faces. This map is going to be used to verify how many sort of occurrences of a face we have. So for example, I'm going to map a face of a card. Let's say we have a 10 of diamonds and a 10 of clubs. All right. I'm going to map the string 10 to the value 2 because given those two cards I just said, 10 of hearts and 10 of clubs, whichever one I said, there's two 10s in that hand. Now I'm going to actually use a picture to draw out the whole structure so you can see what's going on, but I'm just going to review this right now. So faces, we're going to sort of map a face of a card. Remember, faces go from 2 to 10. Then, of course, Jack, Queen, King, and Ace. Every card is going to contain really a string that contains a face and then a suit afterwards. So we'll go over that in a second. So this is mostly used, that faces map is going to be used really to verify 3 of a kind, a pair, 2 pair, 4 of a kind. All of those will be used in this faces map, will help us with that. Then, of course, the suits map, well, it's going to map how many, different suits we have in our hand. So, for example, if I have a 2 of diamonds and a 2 of diamonds and 10 of diamonds, let's say, then the letter D, diamonds, will map to the value 2, implying that we have 2 cards that are both suited as diamonds. So this is going to be used. The suits map will be mostly used to verify if we have a flush. If you have all 5 cards of the same suit, this suits map will be a very nifty, quick way of being able to verify that for us. So now, let's go into the all complicated cards sorted map. So this map is designed to maintain the cards in sorted order. So right below that we have our standard vector current hand. This is going to be used to really, the current hand vector is going to just have the cards that are sort of, you want to preserve the same order as the cards were read in from the input. So current hand is just going to simply, have a list of our cards in the same order they were read in from the user. But that cards sorted map, that's going to be used to sort of maintain our current hand in sorted order, sorted by face. So remember, we have this ordering 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Jack, Queen, King, and Ace. So you want to maintain that sort of set of cards, in that sorted order. Now, it's going to be a string. We'll map to an integer. So we're going to sort of, again, we want to sort of know how many occurrences of a face we have, but I'll sort of draw this out in a second. And this card compare is going to be a third argument we're going to pass into that template. So in main, you're going to have to probably create the following class defined right here. And this class will be used to be able to allow this map to correctly sort the cards, because you can't really just do a string comparison because, for example, if you want to sort of rank, let's say, okay, so Jack is before Queen if you were to actually rank them, right? But the letter, I guess J does come before Q, but I believe, let's say, Ace is the highest card. But if I compare a Jack to an Ace, then obviously if you were to do the default string comparison, Ace would come before Jack actually, which is not correct, not according to the poker rules. So this compare function is Boolean operator. We're going to overload this parentheses operator, which will allow this binary search tree to insert the cards correctly. So we're going to have 2 strings, C1 and C2, or 2 cards. We're going to have 2 strings that are representing 2 cards. And if C1 is a card with a face that's smaller than C2, return true. So for example, if C1, if it's, let's say, a 5, and C2 is a Jack, return true, because this card C1 would be earlier in a possible sorted hand, C1 would go first. So you want to return true then. Let's say if C1 happens to be a queen, and C2 is a Jack, then this function returns false because Queen does not come before Jack in that sorted set of sorted cards sorted by face. So you want to really return true if C1 is smaller, or in other words, if C1 has a face that's earlier in the sorted order and false otherwise. So that way, this map object is going to utilize this operator and be able to arrange the cards correctly. So anyway, this actually would be a little bit of work you have to write in this function, but that's just kind of how it is. So now let's go ahead and go over a possible example and just sort of see how our structures really would update based on how we read in our card from the standard input. So every card you're going to read and store, it's going to be encoded as a string. So for example, card, let's say if card contains 10D like this, then that card is going to be a 10 of diamonds. So you have to be able to separate this into a face and a suit. So this would be the face of the card, that's the number, this is the face, and that would be the suit. And the same idea for these other ones as well. It's a face and a suit. So at least for me, when I learn about poker, I always think a face is like that number or character on the card, and then a suit is really, the diamonds or clubs or spades or hearts. So it's actually very simple to separate this. So for 10 of diamonds, so every single string will have either 2 or 3 characters. So if it's a 3-character string, then it's going to be a 10 of something. If it's 2 characters, then that first character would be the actual face, and a second character would be the actual suit. Now I actually use strings instead of characters because of that anomaly. We have that 10. So because of this, I use strings for everything, because otherwise it would be a little inconsistent. So I use a string to sort of separate, but it's really not too hard. You use a substring function to separate. Of course, use a length function for a string to verify the amount of characters, and substrings to actually be able to extract the face and suit. Okay, so now that we have that part down, let's go ahead and go into how do we actually use our maps to really maintain our hand. So consider the following hand right there. So we read in sort of 5 strings from standard input, and we just simply pushed each of these cards into this vector current hand. So obviously we can use a loop and go through and get all what kind of hand we have. Clearly here we have a 3 of a kind. We have 3 deuces or 3 twos. So we have a 3 of a kind. Let's go ahead and see how we actually maintain our other structures. So for example, we're going to have that faces map. So we go through every card in our current hand. Let's see if we can try to get this actually to fit all this into one frame. Hold on. There we go. Okay. So for a face, of course, for a map, we have this 2 is going to have the value 0. And then, it's going to have the value 1. We're going to add 1 to this. And then the jack will have the value 1. Looking at this card right here, we have a 2. So of course, it's going to, now we have 2 deuces in this hand. Then our index 3 card has ace of spades. So we're going to have an ace will be created with the value of 1. And then of course, we're going to have our final card right there, deuces, 2 of clubs. Then we're going to have to add 1 to this. So now we can see here, we just simply took every single card in our hand and we sort of were able to extract the face out of it, and we simply map it to a value. And of course, use the insert function. Also, the bracket operator can be used for this map to be able to verify, we count how many cards we have in this list. Now, I'm going to actually rearrange these a little bit because I want to put it here just for now on purpose. I'm going to put the 2, 3 right there. And remember, it's unread maps. There's no rule for where they have to be. So let's say, for example, we have it in this type of order. Let's say there's no actual. Any order works as long as they're there. Remember, for unordered maps, as long as we have everything there, we're good. So we have to just simply track how many faces we've seen so far. Okay, now for our suits map, we have to go through each element. So of course, for H, for hearts, we have 1. And then for spades, we have also 1 for jack of spades. For diamonds, we have 1. And then our next card right there, ace of spades, we have to go to spades and add 1 to get 2. And of clubs, we have a new entry for 1. So we simply have to just sort of get the suit out of the card and then map it to a value and add 1 to it. So we just sort of track how many of each type of suit we've seen so far. And now we're going to have our final map, which is going to be, I think it was called our sorted hand. I forgot what it was called, but it's that map. I'm going to call it sorted hand for right now. So correct me if I'm wrong, but that's that standard map object. So in this object, it's going to really be a binary search tree. So when we first insert, now I'm not going to have it be a fully balanced, but of course it's going to balance the structure out. But for now, I'll just keep it keep it simple for, I guess, right now for this explanation. We want to simply store 2 at the very top. It's how I did it. We store 2 at the very top, and then J would go right here next. Then we insert 2 of diamonds. It's a duplicate entry, so nothing gets inserted here. And then afterwards, we're going to have ace of spades, which will go actually right here. Ace goes right there. And then we have another 2, which will not get inserted. So essentially, we have to sort of count the amount of occurrences. So we have 3, 1, and 1. So this sorted list is going to be an ordered map, a binary search tree, and it has the following look. So we have to have it sorted. So the idea is that every node, the left subtree will have all the cards with a smaller face, and the right tree has cards with a larger face. You have to actually manually implement this. That map object does this for you. So we want to, again, have this set up. So of course, this way it's easy to sort of navigate if we have a straight or not. That's the whole purpose of doing the sorted hand. So now we have to use iterators to be able to traverse these structures to figure out what kind of hand do we actually have. Let's go ahead and go into sort of a pseudocode or kind of a rough sketch as to how do we actually really verify what kind of hand we have. Let's get into that part next. Okay, so let's just, I'll give the answers more or less right here, but how do we verify? Let's say I want to verify we have a flush. If we have sort of 5 cards, all of the same suit. Well, how do we verify that? Well, there's 2 kind of ways we can verify that. So of course you can pause the video right here and think about it if you want, or you can continue and of course get the solution. So for a flush, well, if any of these contains the value 5, that means we have a flush. We have 5 of one type of suit. But also another way we can think about it is that if this suit's map only has 1 element in it, that means we know that element, that key field will map to the value of 5. We know that. So if it only has 1 element, we know we have a flush. So that's so hard actually. So how do we verify a straight? And that's a little bit complicated, but what we can do actually is the following. So to traverse this sorted hand, this binary search tree, there's actually 2 ways you can do this. I'll kind of go over both ways right here. So we can have a for loop using this auto type. So auto, I'm going to go ahead and just say card equals sorted hand dot begin. Back to this iterator nonsense again. Then we have card not equal to sorted hand dot end, and of course card plus plus. So this iterator is going to basically traverse this list. It's going to do, I'll put this here, I'll put a comment, I'll put this nice looking bracket here. It's going to, so card sort of traverses the structure using in order traversal. So what happens is it's going to essentially output this sorted. So you have your hand right here. It's in this order, but this is going to traverse them sorted, essentially, sort of by face. So of course, you would output 2, Jack, and Ace. So now, of course, you can just say card arrow first. That's going to give you the card's face, and then card arrow second is going to be, I guess, the sort of the occurrences. How many times that card face occurs in our hand. So of course, that's how you can do that. You can traverse. And of course, you can do the following as well. You can have the following type of loop. So for auto card, colon, sorted hand, this is going to be a range-based loop. And in this sort of body over here, I'll zoom down a little bit, you can actually say card dot first, because right now card is not going to be an iterator. It's going to be sort of, well, it's going to just iterate through this structure. So just bear with me on this. That'll be the face once again. And then card dot second is going to be the occurrences, that integer that it maps to. I think I spelled it wrong over here. Occurrences. Hopefully I spelled occurrences correctly. So anyway, so essentially that's what we can do. So we can go through our list like that using these iterators. So essentially right here, now what happens is, well, we can use this essentially to figure out if each card is sort of consecutive of one another. So of course you can create temporary iterators as well and check the previous element and so forth, but there are ways you can figure this out. But of course this will iterate through everything in that structure, and it's going to allow you to sort of check if the cards are consecutive among each other. So I'm not going to really give out the actual algorithm, but this is going to be really the help that will sort of, you know, figure out if you have a straight or not. Now, let's say over here, for example, how would I be able to figure out if I have a 3 of a kind? Well, I'd have to iterate through this faces map and then check if one of them is the value, the occurrence counter is equal to 3. So what I can do right now is I'm going to do sort of 2 ways just to kind of help us out. I could say for auto card equals faces dot begin, and then card does not equal faces dot end, and then card plus plus. So then if card arrow second equals 3, I have a 3 of a kind. And if I want to know what card it is, well, I could just, you know, say cout. I'll just say card arrow first. This is going to tell me the face of the card that we have 3 of. So in this case right here, it's going to output 2, because 2 is a face card. That's the face of that card that we have 3 occurrences of. And of course, you can modify this again to be able to say, well, for auto card faces, and of course you can just say if card dot second equals 3, then we in fact do have a 3 of a kind. So standard cout, cout, and then just card dot first. So you can see it's a very simple way of figuring out, because since you can assume that you did actually map the card face to an integer in an incremented by 1 every time you look at a card, then you can go through each sort of element in your map and then just figure out which one has 3 occurrences. That second field will give you that amount. Now let's say if none of these equal 3, then we know for sure we can't have a 3 of a kind. It's impossible then. So that's basically how you would do this. Now of course you also can go backwards as well. So for example, you want to like maybe traverse anything backwards. Well, you actually can. You can do the following as well. So I'll just sort of just put this here for you. You could say card equals, I think I'll write this in green. You can say sorted hand dot end actually. And then while not equal to sorted hand dot begin, and you can do actually card minus minus. So then it'll traverse this list in the reverse order. So I mean that way you can actually do that if you wanted to as well. I mean there's no rule for that. Or actually, oh never mind, this is actually going to mess up because end is going to be a null pointer. So you have to actually set, you have to actually set auto card equal to this first, and then do card. Okay, I'm going to probably write this all over again. So I'm going to put this actually down below. I want to edit the video right now, so I'm just going to write this below actually. But if you want to output this in reverse order, let me just put this here so I don't have time to edit the video too much, but I'll put this here. So what you would have to do is you would say auto card equals sorted hand dot end, then card minus minus, because card would be actually a nil iterator. And of course then you would say for card is not equal to sorted hand dot begin card minus minus. This will allow you to traverse it in the reverse order if you wanted to do something like that. So really, once you have these maps all set up, it's just a bunch of checks. You want to kind of go from first royal flush to a straight flush to a 4 of a kind and so forth. But really, it's not going to be so bad, I don't think, because really, I mean, think about it. It's simple to verify a flush. Easy to verify, even a full house is simple to verify. If you have one sort of face that maps to 2, one that maps to a 3, you have a full house. So again, not too hard. Sort of a straight, just make sure that the list of these cards are consecutive. So in this case, since after a 2, next card is a jack, well, a jack is not the proper next consecutive card. So obviously, clearly, it's not a straight. Also, in fact, in order to have a chance of having a straight at all, you have to have 5 elements in this sorted hand map. If there isn't, there's no point even trying to check for a straight, because there's no way you can have a straight. So again, I'm giving out some hints right there. So hopefully you're watching this video, but that's that. So let's go ahead and now go into our our overview of main. And I'm also going to give you a sample run of the program as well. Let's get to that. Okay, so rather than reading the PDF for the main part, I'm going to just simply, give you a sort of a test run of how this program is supposed to work. So of course, I'm going to compile this. So it's going to be just g++ main.cpp, which is one file. And I'm going to run this. So welcome to Video Poker. So of course you want to have your program output that message at the very top, time to randomly generate hand, and of course, I guess I don't want to use random in this program because for one, it's going to be hard to test everything out, and 2, the random generator could be different on code grade versus your machine. So to make things simple, you're going to have to read in 5 cards just so it's more deterministic, just so it's easier to test it out. Let's go ahead and sort of enter our cards in. So I'm going to try maybe ace of spades, 2 of hearts, 3 of clubs, ace of diamonds, And I'll try 10 of, let me see, what have I not used so far? I guess I've used everything, I believe, up to this point. I have spades, hearts, diamonds, clubs. Okay, so I have everything. Okay, I'll just say diamonds. Okay, sure. Hit enter. So now it just gives me my 5 cards with an index value in front of them. So in a regular standard 5 draw poker, you have the option to trade in some cards. So you have up to 5, you can trade up to 5 cards in total. You don't have to worry about, so let me just first, you can help you out. So I'm going to first go ahead and just, maybe I'm going to replace index 2 with, let's say, maybe I'm going to go ahead and just put in, let's say, three of, not 3, I'm going to try, say, 9 of diamonds. Okay, it'll replace that. Now, for you, you don't have to worry about, so let's say I just try to replace index 2, so 3 of clubs, I'm going to replace with 9 of diamonds. Now, don't worry about in your program worrying about what if the user enters 2 again to replace that card. Just to make things easier, I decided not to have that because you have enough work to do already as it is on this assignment, so don't worry about that happening. You can assume that the user will never sort of try to pick the same card again. Okay, so I'm going to try index, let's say 4. I'm going to go ahead and I have ace of spades, diamonds. I'm going to have ace of clubs next. Hit enter, and now I'll type in -1. So you can use up to 5 times for all 5 cards, or you can stop at some point. I'm going to hit enter. And let's go ahead and see. So now it outputs final hands. You have ace of spades, 2 of hearts, 9 of diamonds. I replaced exactly this card, 3 of clubs with 9 of diamonds. So you have to make sure you preserve that order in which you read in, and make sure whenever you replace the card, you maintain that order. So of course, for code grade, it makes it simpler for it to verify your output. And of course, I have ace of diamonds, and of course I replace 10 of diamonds with ace of clubs, as you can see right there. So we have a 3 of a kind, and our output is 3 of a kind, and colon, I just say A for ace. Like I could have said aces, but again, to make it a bit more simpler, I'm going to just avoid that. So, of course, we're going to test out every possible hand combination just because it's better to, you know, it's more official for testing for your assignment. I actually will give you a set of inputs. So here's one input that you could encounter. So let me go ahead and just open this up. So here's the input file you're going to be given. Now you can of course test your program with this. So you can redirect this input into your program. So for example, to redirect, this file is called input01.txt. So you can, I'm going to clear this out for right now. If you say /a.out and then input01.txt, what happens is this input file that I showed you a second ago, so I'm going to go and scroll down here for a second, it's right over here, it's going to feed this in. So we're doing your C in, you're reading from standard input. Instead of having you interactively type in AS, 3D, 10C, it's going to feed this into your program manually. So on CodeGrade, in fact, it does this actually to test your program. So I'm going to now run this, and it gives me my final output. So this just kind of feeds everything in. So let's go ahead and just check this out. So I fed in ace of spades, 3 of diamonds, 10 of clubs, queen of diamonds, and 2 of hearts. Then I want to pick index 3, replace it with ace of clubs, index 1 with ace of diamonds, and we can see here we end up having 3 aces and -1 to end this. So then there we are. So I'll provide you with this input file, and also I'll provide you with a file that's a result of file output redirection. So for example, what you could also do is, and what I would probably do, actually, I'm going to do this, you would just go ahead and just say a.out, and of course I can say output 01.txt like this. Let me go to my folder for a second. So it's over here. So my folder right here is doesn't contain that file, and be very careful not to open up my main file, which has my code right there. So if I were to do this, it reads in my input and it's going to output it to an output file. So what happens now? Hit enter. It creates an output file right there. and it's going to be just simply the results. So I'll give you guys the input output sort of file, which is sort of generated using redirection, and that way you can test out your program out before you submit the code grade. But I'm going to be using the same input output files I'm going to be giving you guys so you can test it, but those same ones will be used on code grade to test using the auto test. So that's pretty much this video. I hope this video did sort of help you get an idea of how to use maps with this assignment. So I guess happy coding, take care, and until next time.